Kia ora, Stefano. Okay, we are going to go through pages 64 and 65. I'm just going to do questions 2 and 4. Remember, don't, pretty much once you see the technique, you probably shouldn't watch another one. You should just go and do it yourself. So the idea of these walkthrough videos is to get the ball rolling or to check what you have done is right. So yeah, feel free to pause the video at any stage and then keep working in your book. Okay, we've got a gradient function. The gradient function is a straight line, so it's going to follow the whole y equals mx plus c. Now, what we're going to have to do is we're going to find out what that is. We are then going to anti-differentiate it, and then we will have a function, but then we have a point that they are giving us, so we will substitute that in. Then we'll have a formula that we can, or like an equation that we can draw the function over here. Okay, so let's do it. So first we're going to have to find m and c. C is going to be the easiest thing to find. C is just where it intercepts the y-axis, so here it is here. Looks like, to be honest, these things look pretty rubbish. Like, sometimes they don't really seem to intercept very well. But anyway, so C is happening at -8. What is the gradient? So to find a gradient, you pick 2 points. That first point's already pretty straightforward. This one looks like a pretty good point. We find the rise and the run. So the rise here, it's rising by 2, and then it's running by 1. Alright, so our gradient is 2 over 1, which is just 2. So we now know that f dash of x is, this formula here, 2x minus 8. So let's anti-differentiate. So f of x, all we do is add 1 to the power, that becomes squared, and then divide by the new power. So 2 divided by 2 is going to get us back to 1. So it's going to be x squared. And then here we just chuck an x on the end to anti-differentiate or integrate that. And then do not forget the constant of integration. This, you've probably already forgotten it many times while going through these questions. Okay, cool. So now we've got a function that we can draw on here, but we've first got to work out where c is. Now, given that the function has a minimum value of -7, so the function's a positive parabola. Right? So the shape that we're going to be drawing is a positive parabola. And what we know is that this minimum value is going to be -7. It has a minimum value of -7. Oh, shucks. So I'm assuming that means that its minimum happens, oh, whoopsies, -7. My bad. So I was a little confused. So we know that the minimum is happening somewhere along here. Minimum value. And that's at -7. Now, how are we going to find out where this min is? Well, actually, to find a minimum, normally what we do is we get the gradient function and set it equal to 0 to find the turning point. Oh, would you look at that? We've already got the gradient function, and we can already see that it's crossing over here at 4. So now what we know is that actually, because we started off with the gradient function, and we know that it's got this value here, we now know where that minimum is. So we know that that minimum happens when x equals 4. So actually, we know it's happening here. So we've now got a point here. What else we know is that this is a minimum value, and because it's like a really straightforward parabola, it's like a no coefficient in front of it, we can actually just draw our parabola on by going across 1, up 1, do a point there, across 2, up 2 squared, up 4, do a point there, across 3, up 3 squared, do a point here. So we could just draw our parabola on right now, but let's do it properly. Okay, so let's first find our c value. What do we know? Well, we've got this point here. I might draw that on. That happens at 4, -7. Okay, so we're going to use that point to find out what our function is. So our output's -7 and our input's 4. So let's chuck some 4s in wherever there's an x. Okay, -7 equals 16 minus 8 times 4 is 32 plus c. So let's start chucking these things across. That's going to go over, become a positive 32. 32 minus 7 gets us to 25. So we've got 25 over this side. 25 minus 16 is going to get us to 9. So that means 9 equals C. Made mistakes before, but seems pretty good. F of x equals x squared minus 8x plus 9. That's our... Wait a second. Does that make sense? Yeah, whatever. Okay. So what you can do to solve these is you could factorize. Is this one nice and factorizable on the fly though? Two numbers that multiply to get 9 and add to get -8. Could we do negative? Wait, 3 and 3. Yeah, there probably is something nice, but I can't do it on the spot on video for some reason. So yeah, you can, because it's a standard parabola and we know that this is our vertex, I reckon the easiest way to approach this one is just to go across 1, up 1, boop, across 2, up 4, boop, across 3, what am I at, -7, up 9, and then we could draw it in like this. It's probably the most straightforward way. Alright, and then we could draw in our parabola. The reason I can't get a nice value with the factorizing is see how that these don't actually, the x-intercepts don't come in at like a nice point or anything, so I can't factorize it. So most of the time you're going to be able to find this minimum value and it will be a, oh, is that going to be nice? Won't go across 4, what are we at, -7, we need to up 16. -7 going up 16, is that there? To 9? 9 plus 7, yeah, so we need to pass through here. And then it has to be mirrored on the other side. Oh dang it, it was going to be such a nice parabola if I didn't screw that up. Oh yeah. Nice! Okay, so that's how we draw it on. Okay, let's do the last question as well. So question 4 on page 65. Okay, so let's just rush through this one, sort of. Where is our intercept first? Damn, they're playing us. That does not look like it intercepts in a nice place. At all. I don't even know what the intercept is going to be. How is that at all helpful? Passes through the point, -2, 9. -2, up 9, both as it goes through here. We know that this crosses over here, right? Now, so that means at -5 is where our vertex is going to be. So we can see that our vertex is going to be here. Now, the reason we know that is because, look, it's going to make us a positive parabola, and the minimum value is going to be at the point where the gradient function crosses over the line. So I now know my vertex is going to be there, and it's going to go through this point. Can I find a nice gradient? Oh yeah. Okay, I can see this is an intersection here. Well, is it just a gradient of 2 again? No, because if it was a gradient of 2, this would cross over. Oh, see how that doesn't cross over on the thing? Like I don't want to. Oh, I don't know if I should say this is the book's fault. Was that actually? Dang it! Look at this. Like, this is nice here. This is nice here. This is nice here. This is nice here. So these are all legit points. But look, it like sort of starts. This is a little bit below here, This is a little bit below here, a little bit below here. And see how it gets further and further going below? Like, the book's making me question myself. Is the gradient 2, and is the intercept happening at 10? Oh, dang it, dumb book. Should we just assume that? Yeah, I'm just going to assume it. Screw you, book. Okay, f dash of x equals 2x plus 10. And so then f of x, and to differentiate that, is going to get us to x squared plus 10x plus c. We have this point here, which happens at negative 2, 9, so let's chuck that in. 9 equals negative 2 squared plus 10 times negative 2 plus c. We've got 9 equals 4 minus 20 plus c. That comes over to get 29, and then it becomes 25 equals c. So we've got f of x. Shucks, I did it off the screen, my bad guys. F of x equals x squared plus 10x. Ooh, that's a nice number. Yes, this is factorizable. This is equivalent of x plus 5 squared, right? Yes. Yes, yes, yes. And that means it kisses, bang, so we know that the vertex is here. So see that it confirmed that the vertex was in fact right there. And yeah, we know it kisses, and because it's just, there's no coefficient, we can go across 1, up 1, and just draw it across 2, up 4, and let's confirm that we go across 3, up 9, boop, boop, boop. Okay, this book tried to throw me off, but it didn't get me. Get out of here, book. Nice try, punk. Okay, I hope that this video has been remotely helpful. If you get frustrated at the book, send me an email. I relay. I understand. The book makes mistakes sometimes. I get it. I get it. Okay, sweet. So that's how you do the things on page 64 and 65. The main tip is that this is already a gradient function. So where this crosses over the x-axis is where your vertex is going to be. That's probably the most helpful thing. Same thing over here. Where this crossed over the x-axis, that's where your vertex is going to be on the other one. And then there's going to be a way to find a point, and then it's just linking up from there.